Okay, let's take away that doorknob. That might be a little better. Okay, so the coloring, have we talked a little bit about the labeling and the coloring, how that's a good, um, feels good to some of you. And I encourage everybody to spend as much time with that kind of stuff as possible. When I study something, I have to do a project and with it that really makes it stick in my head. And when you actually look at uh, I don't know again how many hard sounds there is, but one of my pedagogical grandfathers and mentors was in the 1800s, the guy Pestalozzi, who is sort of credited a little bit to create the school system that then Einstein went through in Switzerland. And he said you got to involve the head, the heart, and the hand when you do something in learning. And the interpretation of that is you got to learn with the head, have a buy-in with the heart, why you want to do it, and then do something physically with the hand to make it stick in the head. And so I think that's fundamentally a really helpful thought or guideline for me, because our educational system is very, very cerebral. It's very head focused and memorizing focused. And it is not necessarily the way the real world works. And so as we go through the school system, I think for me, that was one of those things where I had to sort of do a lot of the legwork. You know, how is this applied to me, especially when it gets into like nursing, let's say, and you start doing exams and things. I always had to organize my own thoughts and my own pathways and how I go through processes with my patients, for example, for me practically, and visualize and so forth to really get to where I needed to go. And those are practical things. Anyway, that's my soapbox. Any other? I'm sorry, it's a little much for first thing, but any other comments, experiences, questions that you have before we get into the material? We finished all the bones. Is that correct?
Yeah, I think so.
Good. So here we are. Look at that. Whoa, all the way week 5. We did week 5. So you guys, if you have not done, and I'm going to do all the day grading today, so I'll be caught up with it again, hopefully. But if you haven't done the office ergonomic thing, at least start doing the last part, which is the exercises, because then next week we're going to have a discussion over it. Not this week, but then next week on that. So that's to close out this ergonomic. Did you guys find this a little useful, doing that exercise? Or not? Hello? Somebody say something.
I haven't done it yet.
Oh, okay. Well, then we'll do that part next week. So then, and this week, we're gonna get into a little bit of the muscle physiology, and we have questions on that, and that's sort of going back to the first part of the class a little bit in terms of when we talked about tissues, and we talked about we didn't go very deep into the muscles because it was just at that point for me it was always overwhelming, so I didn't think it was that useful at that point. But here we have a chapter where we go deeper into the muscle physiology. How does the muscle work? We're looking at the small stuff, also anatomically the small stuff, but then how does it work? And basically how it works is you got all these long muscles here along the forearm. Inside of those muscles you got small little bundles of threads, like little threads. You can have them blue and red, it doesn't matter. They're like tiny little threads, and one of those threads has little heads on it that can grab the other thread and pull on it a little bit. And the other thread has little places where it can connect. So it doesn't really have to grab and hold on to it. So it's like a magnet thing. And when a muscle contracts, which is the only thing it really does, it shortens. That's really all a muscle does. When a muscle shortens, it goes along here. These little threads, the one attaches to the other and grabs it and pulls it a little closer to it, and that slowly shortens the muscle, and then that slowly moves the bones closer to one another where that muscle is attached to. And so that's how the whole thing works, fundamentally. So that's the bigger picture. And then all this chapter does, it goes deeper into what are these little threads called? What are these heads called? Look, I show you, there's some cool. The book has a lot of cool pictures, but there's not that many cool ones I can show here. well, I can show them, but I couldn't pull up the pictures right yet. But you know, that's the big muscle, and then you got these little small tiny parts in it, and then these are these threads that you can see, this green thing and this red thing, and the red one has these things attached to that are heads that pull on them, and that's described in this sliding filament theory. No, we're going to go back to the anatomy, the structure. I think it's deeper down here. Yeah, see, look at these. This red thing has these heads on it, they call them, and these are these things that can pull on the other one, this green one that has these darker spots that are like the magnets that the head can attach to and then pull on it. And if these things pull on this, the whole thing shortens a little bit. And that's, you know, again, fundamentally how the muscle works. And then all these things have names on them. And then you just got to start learning how to put in these names. And so, you know, we then next week, if you want, or later on, yeah, in the class too, we can talk more about these names. I don't want to bring all these names in now because you got to, if you start with the big view, the big picture, we can then fill in the parts. And, you know, the forest. We look at the forest and then we can figure out which are the trees. And so this is sort of the long muscle with threads, and one pulls on the other, one thread pulls on the other thread, and then that shortens the muscle as a whole. That is sort of how it works. And then the sliding filament theory is describing that whole process of how that pulls on it. And one of the things that's cool that is also crucially important in this process is this part here, this darker part, which is called the active site, which is that magnet where the head attaches. And there's this tinier thread that covers that. And if it's covered, it cannot connect. We don't have a contraction. And if it's not covered, it automatically connects. It's a magnet kind of thing. And then we contract the muscle. And the thing that moves that little thread around is simply one little ion. It's calcium. And so calcium becomes a really, really important role in how muscle works, in making the muscle work, sort of this on and off switch of the muscle work. And then once those connect together, everything else is almost automatic, but it relies on energy, on ATP. And so if it doesn't have ATP, it will not work as a machinery, but you might still have the things connecting to one another. And that's what happens when we die, because when we die, the calcium, which is held in tubule kind of structures, in reservoirs that hold it and upon command release it and then suck it back up. So we have this mechanism of contraction, not contraction happen. That integrity is lost when we die. And all the calcium spills into the what we call that the extracellular space, no, intracellular space. And then those muscles, those threads connect to one another, but they can't move. And so that's when we get body stiffness. And they call that rigor mortis. So there you go, a little pathology on that front there. And then everything else talks about the nerves going to the muscle, because ultimately the brain controls which muscle contracts. The ones that are, we have actually 3 types of muscle. We also briefly talk about that. Besides the muscles that we are talking about that attach from bone to bone and move the bones around or make facial expression things, we also have a heart muscle that is the heart that pumps. We'll talk next time in a few weeks. And then we also have smooth muscles, and smooth muscles are muscles in the gut, on the linings of tubes, for example. So they line the gut lining or the blood vessel linings. And so we'll talk about those when we get to those topics. They are just similar, but similar because they contract, but they're different in how they, no, they're not completely different in how they do it. They still have these thread things. That's all the same, but then they differentiate of how we activate them and how long they stay connected and all that kind of stuff. And so we don't really go too deep into that, especially not in this chapter. Then he talks briefly about what energy muscle can use. So that's kind of fun. And then we get into muscle contraction, how we can contract so we can sustain contraction. And then look at that, isometric and isotonic muscle contraction. I actually have a little video on that. If anybody's interested, just shoot me a text. But that talks about if a muscle moves the bones when we contract it, or if it's just holding something, like you're holding a grocery bag, that doesn't move the muscle, but you have energy going into the muscle, otherwise the back drops. And so that's a different, that's an isometric contraction, that term, and then isotonic is when the muscle moves the bone. So you get into that kind of stuff. So then your terminology, probably with this kind of chapter, make really sure, please, this might be a place where you want to have a midweek session and we just connect together and talk about it when you went through it a couple times. And we if you have questions that come up, please just reach out and we organize it once you go through it, because it's, it's a little trickier in a sense that it's how it works. There's a little more language coming in from that end, and it's the small stuff, so it's not as easy to see it. So that makes it sometimes a little bit harder. But once you get that thing that I talked about, big picture, you're cool, because that's the fundamental, and then everything else we can solve really in reality, I think. The thing in anatomy and physiology, the stuff is not that complicated. A lot of it, I think, is how it's presented. But then it's also a lot of it. It's just so much of it. And I think that makes it complicated for us as brains, a little overwhelmed in the head. At least in my head, I get overwhelmed real fast. So if you do, hang with it. I understand you. You can reach out and talk to me. I get it. We still got to do it, but we can do it together that way. All right, then we go after that. Oh, and you have any questions, or you good?
Yeah, I have a question. Okay, so I went over the slides and then the videos, and I was curious about the sliding filament theory. Does that work for all three muscles, and particularly the cardiac muscle? Because that's just kind of interesting to me since it's involuntary.
Yes, it's the filament theory is fundamentally the same in all muscles. But
okay.
Because the level of consciousness just depends on who sends the signal to make it happen. Because as a matter of fact, a lot of the skeletal muscle that we talk about, if we really go deep in understanding it, these are muscle patterns that are also unconscious, and the brain is sort of the influencing figure on it and can direct. So it has the highest command, and then a lot of motion patterns are subliminal. They're not conscious anymore. But the heart muscle is very interesting because it works as a unit. So you got a lot of these small little muscle fibers. They're not long, thready looking like in the skeletal muscle. They're a little bit more spindly looking, like a beginning and then wider, and then at the end they come together again, kind of thing. Well, actually, no, those are the smooth muscles. The heart muscles are more jaggedy at the end, and then they're longer and then jaggedy, and then they connect together and they fill in the space of the heart fascia that way. And then what's interesting with them is then they all talk to one another. And so when they get a nerve impulse to make them contract, and the nerve impulse then, the nerve impulse, basically what the nerve impulse does, it goes and releases the calcium into the muscle fibers. And then the process, then the filament theory is then automatic as long as that calcium is present and energy is present. And then when the muscle stops contracting, it sucks it back up. And in the heart muscle, you just have that all the time happening. Every time the heart muscle contracts, you have the calcium out and then suck it back in, and then calcium out, suck it back in. And when the calcium is present, the little small threads connect to one another, and one of them pulls on the other, and that's the contraction. And in the heart, the thing is, the nerve impulse that talks to the muscle to releases that calcium inside the muscle fiber, then that nerve impulse goes from muscle fiber to muscle fiber and has channels that are open to let that nerve impulse go through those as a unit. And that's why the heart muscle contracts as a unit. So it's like one muscle, not multiple muscles. Does that make sense?
It does. I have a lot of questions that are what if, but I feel like I'll probably save that for later and just text you. Because well, what if calcium runs out? What if your bones are depleted?
Well, that's a good point. That's when we get osteoporosis. That's one reason why it's so important to understand the calcium metabolism. right? Because sorry to cut you off, but come back after, but I want to catch on that because I do think that question is very, very crucial for us to talk about because the calcium is in the bones. And as we grow up, as we are teenagers into late 20s, I would think early 30s, I got to look that number up. That's somewhere there. We grow bones. And after that, we slowly deplete bones because we can use the bone as a calcium reservoir to make sure our blood level of calcium for stuff that we talk about right now in the muscle contraction is sufficiently supplied. The body is smart that way and says, hey, let's use a chemical that we actually have in the body that we can pull from if we need it, if we don't eat enough, right? And so then we can do that. The problem is long term, that calcium gets leaked out of these bones. And then at some point, there's not enough calcium in the bone. And guess what? That's when you fall down because your hip broke, not because your hip broke because you fell down. So that's when you take a step off the curb and all of a sudden you're on the floor and you really, as a young person, you go help these people because they broke the friggin' hip sometimes. And the shock wave of getting the step off the curb was strong enough to break the bone. And so that can happen if we leak too much calcium out of the bone and that solid, strong brick level of firmity of a bone is not there anymore and it breaks easy. And so how can you prevent that? Well, one thing you could do is eat a lot of kale and a lot of that stuff that has calcium in it. And so figure out how you find a format of that you like. That probably does a lot of good, even though, of course, stuff goes back out of the system. That's why we need to replenish it. And so the body will use the stuff we eat ongoingly first, if we can. And then if it doesn't have enough, it goes into the reservoirs. And then that's, where that comes in. If you let's say, you eat stuff society tells us, I should go there maybe. I mean, we're trained to eat stuff that is industrialized. So that doesn't have that many of these chemicals in it. And so, hi, doggy. And so those, then the body doesn't have enough food that it gets supplied with or calcium as we grow up. And so the bones are not as strongly created with calcium. And then once we pull from it as we get older, we don't have as much to pull from. And so, that's where then the double whammy comes in a little bit. Like say we are unfortunately raised in our modern food society, industrial food society kind of thing. So that's where that comes in, and that's why that was so important. Sorry about that lengthy thing, but any other question with that did you have? I want to give you the microphone back.
No, that's good. Thank you so much.
Oh yeah, absolutely. No, thank you. And yeah, again, reach out more if you want more because it's very important stuff. And the connections are not that hard, it's just we're overwhelmed and the internet often gives us so much info if we want to learn something. And I think if we learn some fundamentals, which is what I'm trying to do in this class, then we have a framework to read a lot more stuff through it and understand our body better. Good. Anybody else? Well, if it comes up, just interrupt me. In this class, you get to interrupt me. This is very important. So because I want you to be part of this whole thing. And I want you to understand. It's not just me to, speak things into you. Because if we then finish the physiology, then what we do is we're going to go to the muscles themselves. And now we're going to talk about muscles and we have to name them. And so when we name muscles, as you've seen with the facial muscles a little bit, the names are kind of goofy and interesting. And well, first they're goofy, then when you slow down and it's like, it's not too overwhelming, then maybe they become interesting. And so it is with the other muscles. When we look at muscle, we got these over the next 3 weeks. I'm slowing down a little bit with the terminology. So if you look at that list, of which we will have tonight, we have lab tonight, and we're going to go through the skeleton. So it's going to be a lot of fun. I'm thinking of, well, no, never mind. Last semester I came in a costume, but I'm not so sure I'm going to do that today. Maybe another time. But then we get to the muscles, we separate them into an axial musculature, again, like in the skeleton, the core part, the body go up and down, but then the appendices, the extremities can attach to. And those are then the arms and the legs. And so we have 1 week, first week, this week, we do the core muscles, or not the core, the central, the axial muscles, the core are part of that. And then we do next week, we do the arms, and then after that, we do the legs. And then after that, we have also test over this whole thing. And so I will later on send you or text you and hopefully also email you some drill things that we do in the classroom that I'm going to start doing again. If you have the ability to come to the classroom and be with us in person for a couple hours during the next few weeks, you really solidify that knowledge. And so this is a place where, I know it's a little bit of a work to get up there, but if you can try to do it and even if you're like, I don't feel like it, just kick yourself and do it. It really, really enhances the knowledge because we can talk about it and touch the bones and the muscles and have fun for a little bit. And as a bonus, we also going to go through the postural evaluation tonight. So you don't have to do that as an exercise during the week by yourself. So you can do that with some people and we have fun with it. And it's an easy, makes it fun. If somebody wants to bring snacks, we should do that. I should think about that. But anyway, now we get through the first set of muscles, and those are the axial muscles. Some of my favorite puppies here. Oh, the other thing clinically, if you learn these muscles, you get yourself a hell of a far way in understanding how this whole thing of moving the body around works. So you got actually a really good foundation, because a lot of the other muscles that we get into a higher end class, that tiny thing here and tiny thing here that does this to the little finger, that's like, yeah, that's all right. But when it comes to understanding the whole movement apparatus, those are becoming less important. Even clinically, to me, I'm going to work that muscle much less, never, unless you really have an injury to that little thing, as compared to working on a core muscle when I help somebody feel better. So when we look at these muscles, we can also group them. And what I do is I group them into different areas here: head, neck, back, and then breathing and abdominal front. And then the breathing is its own self, a little bit chest kind of stuff. I often group them by movement, like when we get to the upper extremity, for example, I group them by like, well, who's going to move the arm this way and who's going to move the arm this way, and then this way and this way, and so that way it becomes sort of sensible of understanding it versus it just being a list of nothing. And then the other thing I do in these chapters, well, first of all, I also give you pro tips now, and the pro tips, I don't know what that means. I mean, that's just like if you go a little deeper, if you want a little more, it's not necessarily the fundamentals. You need to look at everything. But I have cadaver clips. And so there is a whole set of, I don't know how many videos I clipped from a series of cadaver videos that help visualize it. And this guy is really boring, talking-wise, but really funny. And British and dry, and there's brilliant. And those clips are like a minute long or half a minute long, or really short for each muscle. So if you don't care about seeing it, muscle bone on it, I mean, if you eat meat, it's really not the same thing. Then watch those when you get to starting, because it helps tremendously to visualize this stuff, right? I use these still. That's why I did these. So I visualize it myself once in a while. I do that. Then here, this is also nice because it's a PDF that is just a set of sheets with muscle pictures on them without any names, nothing. So you can use the whole thing to kind of quiz yourself or color yourself some more. Again, we talked about coloring, very helpful thing to do to put the stuff in the brain. Also, you could cut it out, make flashcards if you work with flashcards and so forth. So that's cool. There's probably more muscles on here that are on the list. So make sure you only really, I mean, you can learn more, obviously, but the ones you're responsible for the test are the muscles that are on the lists. That was the ones that we then do in the coloring labeling exercise. So anyway, then what is this? Oh, then the last thing I have here is my favorite muscle picture. This is an electronic thing. So if you have an iPad or a phone or something, download that. It's this picture with all the muscles on one little picture. And the way the muscles are labeled, and that I'm not showing you because it's going to take for too long to download, and that way you may go look at it. But the way that the muscles are there, it shows the attachments where they're attached, and then it has a line, and it doesn't show the whole muscle and obliterate everything, But that way you can visualize, oh, the muscle is attached here and then here. And then you visualize what happens when it shortens. What are the bones that come together look like? And so I put all of those pictures from a textbook and scanned it and then put it on one picture so that I can zoom in on my phone if I talk to a patient, say like, let me think about it again. Let me visualize that again. And so I gave you that picture too, because maybe one or two of you guys didn't like that and maybe you could use it. So just have a look. So that's this one up here. Have a look, and if useful, use. If not, don't worry about it. That's why these are pro tips. These actually, the reason why I call them pro tips is really because I studied this damn thing so long and so much professionally now that these are sort of the things that help me get the material into a place where I could use it and visualize it. And obviously that makes it much easier to then learn, since this is sort of the first rodeo around for many of you to learn them and get I want to give them to you in a way that I think is the easiest way to get them into the head. And this part I can really tell you from experience, because I'm not just a professor. I do this stuff on patients all day long, and these are McCaffrey type patients, for example. So I really know on this front, I know what I'm talking about. So anyway, I don't need to say more than that. I don't know why I even say that, but sometimes it's, it's hard to know who to listen to or what to listen to, because there's so much stuff. And this one is one that I can probably guide you a little. So anyway, when we look at these muscles, we have an origin. It's a place where the muscle is attached on one side of the bone, and then an insertion. That's the other place where the muscle attaches. And the origin is sort of the anchoring place that the muscle, we could call, originates from, kind of foundation base. And then the insertion is the part that it pulls on, and when it pulls on it, it moves that part. So that's this. A lot of muscles, they do both. They flip. So it's not a given, it's not a set in stone situation, but it's the way it was named. Well, at least that's what I was told, the way it was named. Actually, I never read that up on any Grey's Anatomy textbook or so. Who knows if you can trust Google, right? But it's mostly that way interpreted. But again, they can flip. But if I look at the trapezius, this is the trapezius. Wing, wing, wing. And in the booklets, the pictures are way better. So you should look on those if you can. But the trapezius it originates here on the spine and on the skull, and goes all the way down to the thoracic spine here. And then it goes to the spine of the scapula, the acromion, and in the front, even to the clavicle. So you can see that here. And see, now it's important why you studied all these bony things. And if you haven't yet, go make sure you do that. And don't just layer on more before you do that, because there is a little logic to the crazy madness over here. And then lastly, we have the action. And the action is, well, for us, lastly, we have the action. And that is, what does it do? And so in the trapezius does multiple things, because it moves the trunk around, which is what we talk about now, the axial skeleton, the head and stuff. But it also ends up moving the shoulder around, because it's attached on the shoulder. So that is where this, here I describe what it does to the head, and a little bit what it does to the scapular motion, but I also describe it in the upper extremity. So if you want to look at that when you do it, go there real quick. I didn't put it here. I don't remember why. But there was a reason why. I think it was probably because I try to be minimalistic on the text and maximalistic on the pictures. But that's the action. And again, for you guys, it's about visualizing this stuff. This is here to visualize it. Then I would do what I would do. Then I would watch the cadaver clip. And then after that, I would go label it and color it. And then, because on the test, all you got to do is, when I say, what's this called? You say it's called the trapezius. That's all you got to do. You don't have to know any of this stuff for the test. This is integration material. Or let me put it this way. Yes, it is integration material to understand what the point of this whole muscle is. And if you don't, you should care about that. That makes studying much, much easier and learning. But this is also in terms of the usefulness part, right? This makes it useful. The test really just helps me understand and keep you guys on track of what we're doing. And I try to design the tests in a way that it guides you in the studying, And it also helps you. It's like, we're finishing up something. It's last work through it. And it's kind of like a little bit like, oh, look, I knew that. I can do that. Because, if you study hard, I mean, this is very interesting for me. I never knew that until I went to Bill Romanowski's house, and that he's the football player at the NFL that still played the most games without missing a game. So anything he told me to learn, I went to go learn, believe me, because he knew everything he needed to know to play 17 years as a linebacker and never miss a game. And he was also, if you look him up, he was crazy. But I worked on his inner thigh muscles one day for like a couple, 3 hours, because he had some injury. And then I went home and I studied those suckers. And I did this video clipping. I did material I have that I can give you if you want that really shows the muscles detailed and more detail that I use for myself sometimes to reference back, but also really use to just study it. And then I went back the next day. And so that study session was probably about 4 hours. And the next day I went back and he says, dude, what did you do? You're much more precise now than you were yesterday. And I realized one study session can do that. And that, to me, working with him, that meant his wife called and say, hey, you want to work on McCaffrey? And so I was able to do that. I am not sure if it was exactly that moment, but that's what that does at the level of where I thankfully was able to work as a massage therapist now. But this is why this stuff is what you do, whatever you do in diligence and going deeper in it instead of just focusing only on what I need to know for the test is really valuable. And if you go to a higher end class, you know the stuff at that point, and then you can, maybe you know a little bit more, but not much. The other thing that I don't have in here, besides I have the action, right? And the origin insertions, I just call it OIA. And then the only other thing I don't have in here is the innervation, because every muscle is fed by a nerve from the brain, spinal cord, and they call that the innervation. And to me, it's just too overwhelming. And I actually measure that on myself, because that's the one thing that I always went way over my head. It still does. It's still, if you ask me which muscle is innervated by what, I gotta kind of have an idea, but I still gotta look it up because it becomes too overwhelming for my ADD brain. And so I figured, especially in the first time around, we don't have to go add that on. And so if you do a higher end class of Bio 2 or so, then you might have to do the innervation with the muscles too, but that's about it. So you just go through all these muscles, kind of cute. Look at the pictures, really interesting. How you have a superficial layer and then you go deeper, and then here the deeper layer. And look at the deeper layer, it's really weirdly deep. And these deep muscles, I work these all the time on people because you got back pain. This muscle, had they found out neurologically, it's not working. It's turned off. And it's in the booklet, there's a picture of a cross section. It looks white. It's not muscle tissue. Muscle tissue on an MRI looks dark. And so we can actually re-bring that back. And so that's kind of interesting then to know that, because then I'm doing, the PT gives me a Superman exercise or something because I need to strengthen these muscles. You understand why. And then, you know what? We have found then we are more likely to do it. Because why would I do something I don't understand? See, that's one thing I never understood. And then anyway, breathing muscles are the ones. Did you know the lung is attached to the chest wall from the inside? And then the chest wall expands. And when the chest wall expands, that's the breathing. So it's really muscles that do the breathing. It's just the way it's activated when we inhale. That sort of happens up here in the unconscious part of the brain, which is the bottom part of the brain. So that's kind of cool and interesting to understand too. So it's the suction that is what does the inhalation. It's the expansion of some volume, and then the air has to come in with that. That's suction. And so that's really the breathing. So there we go. We already talked a little bit about breathing. And then lastly, on this section, we do the abs. And the abs have a lot to do with the core also. The core, have you heard of the core before? Probably, right? Anyone who's still here? The core is really important that this part of the front, this part here, well, actually, this part, the chest is like air in here. That's the lungs, and that's the rib cage. So the core part, that's, it's important, but it's less important than down here, because down here we got muscle that creates the stomach wall. And so Look at my pooch. This is what I look like. He's asleep now. Yeah, and he just had a deep sleep, so he's happy when I talk, I guess. But the more we can have that be solid as we, let's say we walk, and it's not like wobbly walk, it's like solid walk, like not military, but solid. And then the extremities that come out of are coming out of a solid place. That is much better than if it's wobbly. Up here, it's much easier to explain. Because if we have a strong core, it also has an effect up here, even though this is more bony the way it holds together. But if we are strong, we can move this arm from a strong place. Nothing moving here, just the arm moving. If we are wimpy in the core, everything moves. Can you imagine how much more movement is on that shoulder when that is the case? And that shows you and then how much faster that shoulder will wear out, because shoulders wear out. You get frozen shoulder and all kind of stuff when you get a little older. And so that's where the core becomes very important. And we talk about that a little bit in this section of the video. So I think this is also kind of useful and interesting. It's different layers, basically. You got the six pack on top, and then you got some on the side that come in a diagonal angle on two diagonal. One going that way, and then the other one going that way, more or less. So you have two layers, and not superficial and external, and the deeper one, an internal, they call that. And then deep on the inside, you got one that wraps around the gut. That's this one here, the transverse abdominis. And that's actually the one that's credited the most. It's tiny. When you go to the cadaver lab, it's like skinny, although these are old people, so that, but it goes straight around the stomach. Kind of thing, and then that really holds everything together, and we teach that to patients with back pain. We call that abdominal bracing, just holding your gut in, making your gut tight, and learning to make it tight that you're still breathing. That's abdominal bracing, and the more you could do that, the less problem you have in your back, because the more you stabilize the low back. And I talk in the booklets about it. I got like these meshwork looking things that you can see why that is the case. So it's kind of interesting. It's like a lumbar brace. Have you ever seen a lumbar brace? Like these things that wrap around the low back. They do it. Like if you go to Home Depot, people sometimes, well, I don't know if they're still doing it. The workers still do it because it wasn't really efficient. It wasn't really effective. But that the low back is doing that on its own with the stomach muscles. When the stomach muscles are good and strong and contract, and you do abdominal bracing, the back part is like a low back brace, the way it protects the back. So that's kind of cool. Anyway, I'm talking. What else? There was anything? Something else. Oh, yeah. This is what was so interesting, too. When I was working on, that was Brice Butler. He worked for the Raiders for a few years, and he's retired now, but he was really cool. He's on my website. I worked him in February for a shoulder, but I worked down here. And this muscle, the multifidus muscle, which is also one of those really, the one that gets weak, these ones that get weak when we don't, when we have back pain. It was not that strong. It was regularly strong, because they didn't have training. And then they went to training. That thing grew this much in about a month. It was unbelievable. And so that was another place where I'm like, holy cow, this muscle stuff is really, there's something to it. It's really like, look, you go to the gym and get buff, but, when it comes to some of these muscles, it's more about being strong enough that we don't put too much pressure onto the rest of the skeleton, for example. Because, you got to understand that. You got to think about that. Muscle contracts. That's all it does. It shortens. Well, that's a shock absorber. So if you have a muscle that contracts a little and then the shock comes in, it lets go a little, contracts a little more, has the tone, the baseline contraction to it a little bit. That's a shock absorber. If you don't have that, you get boom, boom, boom. You can only imagine how fast the joint wears out like that. If you, for example, look at the lumbar spine. Now that you studied it a little bit, you can sort of visualize that. And that's, that's stuff that makes it then more, to me, I want to tell you these kind of things because it makes it more, why should you care about it? But that's why you should care about knowing some of these things. And so if you get to studying and into this material motivated like that, you'll get through that stuff in no time, because the details of the names, I know that's the stuff we have to test you on, but that's at the end of the day not that important. No, don't say that. We got to know what it's talking, but it's more important to know why. Anyway, you got to do a labeling. And then we're going to do the posture eval. If you show up in class, you're going to do that tonight with me. I got to prep for that. But what you do is, look at that. I didn't have a beard then. I'm about back to that weight. My COVID booty is gone. But I showed you how to analyze your posture a little bit, and you walk through that, and you take a picture of yourself. This is tripod, or lay the phone somewhere or something. And then, you know, you can have a timer, and then it clicks in like 3 seconds or 5 seconds. And then you take that picture and you make have a few landmarks that you indicate. They are spelled out, where you put some, and then you make some lines and connect the landmarks. And then you translate that onto some, well, you don't have to, but no, this one I want you to actually, if you can, onto sort of a schematic. So then you kind of see a little bit, wow, I'm a little crooked compared to the normal. And the big one, and then we're going to talk about the big one that shows up, you know, hint, hint, if you watch this, the big one is usually the head forward. We're usually all sitting a little bit too much like that, you know, not the head back, you know. And guess why I'm doing this posture evaluation? So I do mine twice a year because mine is not that good. But you do that, and then the second part is, and look, you can even watch a video, somebody doing it. It's a PT, it's a good video. And then the second part, we talk about exercises a little bit. Then I want you to go through this, and I want you to answer a few questions. Then I thought I had a thing where I want you to.
I actually have a question.
Yeah, talk, please.
So like, I used to have really good posture, and then I got into a car accident and I fractured my L1 and my L2. And I like lost all my posture. My back, and like, I don't know, I don't sit right and stand right anymore.
Is it painful to sit and stand right, or is it just a lot of effort?
A lot of effort to sit right, but like when I stand, I can't stand for very long. It starts to hurt.
And what kind of we can talk offline if you want. We don't have to do it in public, but if you don't, we can keep doing it here too. What kind of fracture, if you don't mind asking?
I would have to look on my paperwork.
Okay. Because
yeah, I'm not.
Yeah, I mean, that's certainly, we're gonna have a different conversation when you have a condition like that, how we can mitigate and figure that out. And I would like to talk to you about it and help you figure that out a little bit if you're okay with that. Because
Yeah.
certainly want to be, because if it comes to why is posture really important? The reason why posture is really important for us, you know, other than the mom telling you all the time, do not stand so crooked, is if I stand like this with the head forward, which is one of my bad proclivities, and gravity always pulls everything down all the time, you got to weigh around in here. It's going to get tight. Your bones at some point going to get arthritic, and you know, it's a problem at some point. The big problem short term is actually not about it's really about the energy. It takes more effort to keep a head up. It's in the booklet, that part, or in the pamphlet for working the ergonomics. I think a head forward an inch is like doubling the weight or something, 10 pounds more on the head, how heavy it is. And so that takes a lot of muscle energy in the back. And so you get tired much faster in the movement, in the muscle bone apparatus, if you always do the phone like that. I mean, I literally had this patient. I think I told you the other day. I had this patient that came in. He could not lay down. And I thought he had to go to the ER. I have it on a video. And I had the video on, and I said, oh, I don't think I can help you. Let me try this one thing. And I took my little hammer tap around, and I tapped around the rib cage where the problem really was, but not tapping what really hurt, because I couldn't touch that. It was too much. It was like a wound. And he started getting better. And so then he was sitting up, and he's got his phone to text his wife something, like, and he bent all the way down. And I said, like, what are you doing? And I'm saving battery. And it's like, it was dark. You had to go all the way to the screen. I'm like, dude, nah, at least hold the phone up like that. That your posture, you can only imagine. You're you know, they used to say, don't walk like a monkey. They used to tell me when I was like, ugh, as a teenager, you know, a little depressed or something, and or melancholic, I should say, or deep in thought, maybe I should say. but so that's why posture is that important, right? And that's why I want you guys to do that. So it is really important. Yeah, that if you're okay with it, I'm happy to talk offline and help you with your situation on that.
Okay.
Because we want to figure out what you can do for that pain too. I mean, come on. It's not supposed to hurt after a while. It's tough.
Yeah. Well, and I also didn't finish physical therapy, so that could be
Yeah, but that's
another.
okay. Yeah, but now it's time to pick up the conversation again, maybe. So it's okay. You know. Well, this is the stuff we kind of have to work together with each other because we all get chronic pain. And at this point, I'm literally calling the mismanagement of chronic pain in the medical insurance industry a civil rights issue because it's so prevalent. And I know it's going to tick people off probably, but it hasn't so far. And everybody so far that I talk to that knows what people are talking about, they go like, yeah, you actually got a point, because it's influencing us negatively by medicine looking at muscle and bone issues and things like you're talking about from a perspective like we can cut something out and then it's finished and gone. That's like you're looking at something like it's a virus and not and ongoing things like it's asthma. And when we learn about back pain, for example, it's asthma, it's episodic. We learn you have something going on physically that goes on under the radar, under the subliminal, not pain level, which is great because you don't want to be always in pain. But it comes back up, and we don't work on functionally helping what that thing is, that physical thing. We just look at the pain and numb it or cut it out. We're not helping the system as a whole. And so that's where we have to do better. And that's where you all come in, knowing these things. And I'm serious about that too, because I'm actually in America because my back is a bad back and I'm still looking for help. And I've learned I had to actually study the damn thing and work on levels like, the athletes and stuff to actually learn stuff that is that useful at that level. And so I'm again soapboxy, but I'm sorry about that. But it's important for me that you guys understand it to some level, and because medicine is really brilliant, and I don't want to bash medicine at all. I just feel over the decades that I've worked with the medicine, I've been the chiropractor for all debates for 20 years. We need to fill in gaps that insurance, medical, with the massive medicine that we have to provide for everybody, that we all part of and help. But we need to do as much as we can to help the whole gestalt. And some of the stuff is missing, and we need to fill in the blanks. And sometimes that just means we know a little bit more, and we can tell somebody who's suffering that, like, hey, maybe we can help you a little bit. It doesn't have to be always the pill. Or, I have one MD, pain specialist, really cool guy, worked with me a lot. But he had one patient that gave him a lot of learning. He was a guitar player and he had carpal tunnel. And he says, dude, I don't think you should play anymore because it's gonna no. The guy went out and killed himself. Nobody has the monopoly of what works and what don't work. Could be that some miracle person holds his hands, like my dog, for example, and his hand is perfectly fine. We don't know that. I have learned techniques they're freaking voodoo. I mean, they're like, I have to pray on points and feel energy going through points. I'm like, how the hell is that going to work? But I'm doing that on people like McCaffrey. That's the level of, and then, it's not voodoo. It's really some stuff works and some stuff, we don't know everything. And so we have to be humble. And so the more you know about your own body, the more you can be respectful of your own body. And that's, part of that, why I'm doing this thing. And that's why I want you guys to be open as much as you can and talk to me about these things, online or offline. Okay. Anyway, that's all I have to say. I think because the rest of the week is easy. That was it. The posture eval, and then the rest we finish up with a question and tips. And I'm really grateful you're doing this. I'm catching up with the ones that I'm a little behind. And then with that, this week is also over. Any questions or last comments from you guys?
So I'm actually coming to class tonight. Could we talk after or before?
Yeah, absolutely. Yeah, probably. Either or. Yeah. I usually get there a little bit early, setting up, and then we can talk if you're a little early, and afterwards I can definitely stay as well. Or during. Good. All right.
Thank you.
Thank you. If nobody has any other questions or concerns or comments, we can close it out. Thank you for being so attentive today, and I'll see you all later on.
Dr.
Thank you.
See ya.
See you.
Hey.
Thank you. Bye.
Thank you.